All right, got a new idea here. I'm going to draw it out. Your source battery. You're going to take the power out of this source battery with the diode right there, and a 50 ohm resistor right here. This diode's a low voltage diode. After the diode, you're going to feed a 20 farad capacitor bank. It's going to be in parallel with another capacitor, high frequency capacitor, 47 microfarad. It doesn't have to be high frequency, I don't think, unless you're going to be up in the high frequencies. But it doesn't have to be exactly 47 microfarad. This is just a value that I know you can find out there easily. And that will be in parallel with the 20 microfarad. I'm sorry, with the 20 farad super cap. This is a super cap bank. Let me do this correct. So yeah, this will be a 20 farad super cap, which you can find for about $15. I found one on eBay. Amazon has a 2 farad. This is, by the way, this is a 20 farad, 16 volt. eBay has them for like $17 after shipping. And that will be in parallel with the high voltage capacitor. You know, so the reason that's there is, hold on, the high voltage capacitor right here, it's there because in case, okay, by the way, in this circuit that I'm doing, the flyback, the positive flyback is sitting here and the negative flyback is sitting here from the inductor. This is just the power supply for this circuit and how I'm going to arrange the power supply to separate the flyback and the actual battery and from the capacitor bank. So the flyback is going to be hitting these 2 points, positive and negative flyback. Also, keep in mind, I don't want that flyback to reach over here. That's why I have a 50 ohm resistor here. And the diode's not there to block the flyback. It's there to prevent any of the capacitor from charging the battery. And to help also block the high voltage going that way from the flyback that hits these 2 terminals. But the high voltage that makes it across the resistor and the diode will end up hitting this capacitor. I anticipate most of it will rather go here because the internal resistance on this battery is somewhere around, 5 milliohms, very low resistance. So having a 50 ohm resistor here kind of, helps the flyback make a decision where to go, to the lower resistance. So when you're talking 5 milliohms, that's a very low resistance compared to 50 ohms. But just in case, I'm sure some voltage will cross with next to 0 amps, given that this is going to block most of the amps the flyback has, and shove it into the battery instead. But any voltage that crosses, high voltage, will end up here and protect the supercap bank, which is rated at 16 volts. And they will, push it into here later. So that's that. And that connects there. And like so, you are going to be hitting the flyback here and here. And we want it to all go in the battery. What's going to go in middle right here is switch. That switch will be controlled by a transistor and a function generator together. Hold on a second. Switch A, we'll call it. So switch A is the positive. You're going to switch the positive. You can switch the negative too. But for whatever reason, I'm going to switch the positive here because it makes more sense to do it that way. So switching the positive with switch A, and the negative connect, like so. So your negative connects there, and this side is going to feed the inductor. This is going to be your supply power for the double pole, double throw relay. So off of here, you're going to take your positive, you're going to take your negative here, you're going to switch the inductor with the double pole, double throw relay, using this negative here and this positive here. This becomes your positive here, your negative. Source power, which will connect. Give me 1 second. It should connect to pins. I'm looking at the relay. Pins 7 and 8 of the relay. 8 is your positive, 7 is your negative. Oh no, I'm sorry, pin 5 and 6. No, sorry, 7 and 8. 7 and 8 is your common, call it plus and common minus for the relay. Those are the common leg pins of the relay for the plus and minus rails. From there, you're going to send a signal. You're going to send 12 volts plus and minus to pins 7 and 8. 8 is your plus. You can trigger this pin 7 with a transistor like I am doing. I'm triggering the negative with a transistor and a function generator in order to set the frequency of the double pole, double throw relay. And that happens on pins 7 and 8. Pins 5 and 6 is where you're going to connect your power supply that you see here to that relay. Okay, and this is the power configuration for the relay. Let me title that here. And then from there, the relay will make contact on the inductor, and by 2 times. One time one polarity, the second time the other polarity. Pin 5 and 6 are the common plus and minus rails that you feed the relay. Pin 7 and 8 is where you energize the relay to flip it, so it flips. And the other pins are the pole throws. So what's going to happen here, one more time, I'm going to run through here, now that I got this drawn out, is by using a capacitor ring right here. Oh, I got to type this in too. Switch A. Switch A, you control it with a timer. The inductor I plan on loading on this relay is going to have about, hopefully 150 ohms around there. And, when you send 12 volts divided by 150 ohms, it's like 80 milliamps. So, okay, so you know that your, flyback inductor's got about 150 ohms with a 12-volt supply. So 12 divided by 150 is 80 milliamps. So you're only going to pull about 80 milliamps on your inductor, and with a 50 ohm on 12-volt supply, you can push 250 milliamps. So when switch A is closed, you can quickly push a quarter amp into the supercap bank, right? And once you dump it in there, a quarter amp for a pulse, and having this capacitor there helps to catch all of that right away, because the supercap takes longer to catch the voltage than the other one here. So this will catch that pulse and fill up right away, and this will also catch the pulse from switch A closing. It closes. So having it like this, when switch A closes and fills up the capacitor bank for that brief period of time, since we know that you're only pulling 80 milliamps on your inductor and it's being pulsed, so you're probably pulling less than that. And if you close this switch, whatever. Let's say you're pulling 80 milliamps on your inductor and you have 250 milliamps that you can send this way for a pulse. With the correct timing, you should be able to keep this charged so that it doesn't fall too low of a voltage and it continues to supply your circuit. And when the gates open here, the flyback gets to hit these two terminals uninterrupted, meaning the battery is getting the full impact of the flyback when this is open. And that's the goal of having that switch there, is to have the flyback touch only the battery. Okay, it's not drawn here, but the inductor pins from the flyback inductor, it's going to go to here and here. Okay, that's the flyback inductor. Of course, you got your high voltage diode there, and you have the negative high voltage diode facing that way. So when this coil flies back, it smacks the positive and the negative. And when it does that, while this gate is open, it's going to hit the battery all by itself, which is what I want it to do. And that's the idea behind this switch.